Hi there! Today we're going to be talking about Nikola Tesla's famous invention, the Tesla coil. The Tesla coil is a radio frequency oscillator that drives the air core double-tuned resonant transformer to produce high voltage with low currents. They are used to produce fantastic high voltage, long sparking displays. Fun fact about the Tesla coil is that it was the first ever system that could transmit electricity wirelessly, in that time where people are still learning how to harness its potential properly. To be honest, I was a bit shocked when I learned it was the first system to wirelessly transport electricity. I was like, what? Anyways, let's get started! So the materials needed for this experiment are magnetic wire aka anomaly copper wire, 22K resistor, 2N2222 transistor, a breadboard, ordinary breadboard wire, any non-conductive cylindrical object, 9 voltage battery or just a 5 voltage supply battery, and last of all, the LED light bulb. Did you know that LEDs contain no mercury and at least 95% of an LED is recyclable? Not only is it more effective than the incandescent bulb, it also makes the future of a greener technology seem bright and near. But before we proceed to the experiment, we must prioritize our own safety first and always be careful in handling our materials. In order to further increase your knowledge about proper etiquette, here is a list of the most important ones you need to remember. Number 1. Follow the instruction. Number 2. Wear protective clothing. Number 3. Know your materials well and what they can do. Number 4. Know the location of safety equipment. Number 5. Be responsible and stay calm when accidents happen. So now that we have knowledge and proper etiquette and have the materials ready, let us now proceed in performing the actual experiment. First, take the PVC pipe and wind 300 to 400 turns of 28G copper wire. Next, apply tape at the bottom and wind 4 to 5 turns of 22G copper wire. Now, remove the enamel of copper wires at the end. Solder 22K ohm resistor to the base of 2N2222 transistor. Solder the bottom end of wire of primary coil to base. Solder one end of secondary coil to collector. Solder positive terminal of battery clip to switch and negative terminal to emitter pin. Now solder another end of secondary coil and another pin of switch to the free end of 22K resistor. And we're finished! Now let's test it out if the LED bulb lights up. Wow! That was a shocking result! Who could have thought that a single brilliant mind invented this way back in the 1890s? Technology back then was bulky and ancient compared to today. Nobody expected such a great invention would come from that particular time in human history. But anyways, enough about history. Let's talk about why and how that happened. The power of the Tesla coil lies in a process called electromagnetic induction. A changing magnetic field creates an electric potential that compels current to flow. Conversely, flowing electric current generates a magnetic field. When electricity flows through a wound-up coil of wire, it generates a magnetic field that fills the area around the coil in a particular pattern. When huge amount of energy is transmitted through the coil, the magnetic field is exploited, resulting in the release of electric power. So based on the explanation, it comes to show that Tesla coils use electricity and the magnetic field in order to make the light bulb light up. So in order for you to understand the Tesla coil further, I'm going to discuss what is electricity and what does have to do with it. To begin with, Plasma is one of the four fundamental states of matter. It is produced by heating a gas to an extremely high temperature, which causes such vigorous collision between its atoms and molecules that electrons are free. One of the best examples of this is electricity and lighting. Did you know that plasma are the most common state of matter in the universe? Since plasma requires heating gas to high temperatures, stars have been observed doing by the means of nuclear fusion, wherein the stars produce energy by fusing together two isotopes of hydrogen in order to produce helium. So now that we know how to build a Tesla coil and how it functions, where is it used in real life? Back in its early days, Tesla coils were used for wireless telegraphy, radio transmitters, and early models of televisions. However, they have been replaced by modern systems now. Nowadays, Tesla coils are used in X-ray scanning by using high-energy electromagnetic radiation to pick up the vision of the bones. It is also used as a transformer, carrying multiple circuits to provide electrical energy for the community. But even though most of us know Tesla coils are mainly used for educational and entertainment purposes, smaller coils are still used as leak detectors for high vacuum systems. This brings us to the end of the video. We sincerely hope that you enjoy and learn something new. And always remember, please be careful in handling electrical equipment. Bye-bye!